All right, for problem 22, we have a little problem here dealing with some money. You have $12,500 that you want to invest in a mutual fund for your retirement. The mutual fund earns on average 8.9% interest per year. Now we're going to look at this problem in three different ways. The first way, we're going to look at our interest compounded monthly. In the second place, we're going to look at the interest compounded continuously. And finally, we're going to figure out how much time it will take for our money to grow to $1 million. And so on part A, we have how much money would you have in your account after 30 years if your interest is compounded monthly. So we have A of t is equal to, anytime we're compounding over a period of time, our equation is the principal times 1 plus our rate divided by n, where n is the number of times we compound, to the nt power, where t is the number of years that we're compounding. And so for our equation, our principal was 12,500, so we'll have A of, well, our t is 30 because we're looking for the amount of money we'll have after 30 years. Our principal is 12,500 times 1 plus. Our rate is 8.9%, so that's going to be 0.089. Remember, we just divide the percentage by 100 to get the rate. And it's compounded 12 times a year, so that's n is going to be 12. That's the number of times you compound per year. And so if that were quarterly, you would put a 4. If that were annually, you would put a 1. If that were semi-annually, you could replace n with 2. Semi-annually means you'd get the compounding twice a year. And we're compounding 30 years. And we're just going to plug this into our calculator. And when we do, we're going to get that after 30 years, we'll have $178,729 and about 96 cents. So the next thing we're going to do is we're going to say how much money would we have in your account after 30 years if your interest is compounded continuously. And the difference here is the way that you calculate continuous compounding is we're going to use E. And so we have P, E to the RT. And we're familiar with all these terms. P is the principal, R is the rate, T is the time. And once again, we're looking for A sub 30. So we put 12,500 times E. Now, and when we think about this problem, we should be thinking about this answer, since it's continuously compounding, should be slightly more than our last answer. And when we plug that into the calculator, that's exactly what we find. This is going to end up being $180,499.61. If you're using the TI Inspire, you might get a slightly different answer here, as I was using Desmos. And so now we're going to look at how long it takes for our investment to be worth $1 million. And we're looking for, assuming the interest is compounded continuously, how long would it take for your $12,500 investment to grow to $1 million? So here we want to know, well, when is it going to equal $1 million? And we still have our same equation from part B because we're compounded continuously again. So this is E to the power 0.089 t, because we don't know how many years this is going to take. So the first thing I'm going to do is I'm going to divide by 12,500. So let's take 10,000 over 125 is equal to E to the 0.89t, 0.089t. And now to get rid of the E, we're going to take the natural log of both sides. So we'll have the natural log of 10,000 over 125 is equal to 0.89 0.089 to the t. Remember, we're just pulling this out front using our properties of exponents. And then to solve our equation, we're going to divide by 0.089 on both sides. And if I plug this into our calculator, we're going to get t is equal to about 49.24 years.